So in this section, we're going to talk about similar figures and using our scale or we're going to bring in scale factor now of what we can use it for when we are comparing our different similar figures. So if it's a similar polygon, this is the big one we're going to see. Two polygons are similar if the corresponding angles are congruent and the corresponding side lengths are proportional. What that means for the proportional part is that the side lengths have to have the same equal ratio. And that would be if you compared all of the sides, the corresponding sides together. So in this first example, if you see, we can still use our similarities statement right here to line up our letters like we did when we had congruent figures. So that means that angle A is congruent to angle E, B is congruent to angle F, C is congruent to angle G, and then angle D is congruent to angle H. So our angles are congruent. For the ratios of the sides, we need to pair up our picture, or if you're looking at it the same way, AB is going to be proportional to EF, because remember we're setting up ratios. BC then would be over FG. CD is proportional to GH, and DA is proportional to HE. So we set up ratios, they're not congruent. Remember that they're going to have the same ratio between them. So here's a big vocab word you're going to start to see, and that's scale factor. So if two polygons are similar, then the ratio of the lengths of the two corresponding sides is called the scale factor. So think of, in that last problem, that when we set up all of our fractions, the number that it reduces to is the scale factor. We're going to write it as a fraction. So in these two triangles, it is shown that, or is said that they are similar to each other. So we can list all of our pairs of congruent angles. So we're going to start with our angle R is going to be congruent to angle X. Angle S is congruent to angle Y. Angle T is congruent to angle Z. Remember, I'm getting that from right here. I'm not looking at my picture. So next, I want to pair up each of my sides. And I'm going to do my big triangle over the small triangle. So whenever I'm getting my numbers, I'm going from the big to the small. So big over the small is how I'm setting up each of my ratios. So I'm going to line each of these up. So 25 over 15. If I reduce that, that becomes 5 over 3. Next, I'm going to do my 30 and my 18. So 30 over 18 reduces to 5 over 3. Next, I'm going to do my 20 and my 12. So 20 over 12 also reduces to 5 over 3. And that shows that because all the angles are congruent and all the sides are proportional, that this is a similar triangle. So if we need to write the ratios of the corresponding side lengths, we're basically taking each of these ratios that we set up right here, but we're putting it back as the actual letters, not as numbers. So if you take a look, you can see that RT is going to be proportional to XZ, TS is proportional to ZY, and RS is proportional to XY, and that's what I've got right here. And we can only do this because all three of these ratios of the sides are all congruent, or they're all the same number. So that's why we can actually write this proportional statement. So next we need to write the scale factor, and really the number you found up here, so the 5 over 3, 5 over 3, 5 over 3, that is the scale factor going from the RST triangle to XYZ. So to determine if the polygons are similar, we need to figure out if all the angles are congruent and if all the sides have the same ratio, so that they're all proportional to each other. So one thing that you can check real easily is with our angles. If you look at them, they are all the same in our picture. So we've got one that's right triangle or right angle, we have 2, we have 3 little arcs, and we have 1 arc. So all of our angles are congruent. So next we have to check our sides. So if we check our sides, I'm going to still do big over the small. So if you look at the name of each of them, so you always want to keep the setup the same for each of them. So if I chose this, I'm going to do my 25 first. So 25 is going to be matching up with my 20. The 15 is going to match up with the 12. My 20 is over my 16, and then the missing side that I don't have is my 30 over the 24. And if you reduce all of these, they do come out as the same number. So that would be 5 over 4. So those are all the same. Sorry, some of those are a little sloppier. So yes, we can say that the two polygons are similar, and it said if they are, write a similarity statement and find the scale factor of the two of them. So first off, for the similarity statement, we need to pair up our different letters. So we can say X, Y, Z, W is similar to, and then do it in the same order. So H, G, F, J. My scale factor is going to be this number that I found already, and that would be my 5 over 4 is my scale factor. For the next triangle that we've got, we always have to decide how we're going to set this up, and I'm going to use my small, and this is my bigger triangle, so I'm going to set up my small triangle over the large triangle. And you might wonder how I know if that's the big triangle, but if you look at the numbers on them, it's the larger triangle. So one thing I can do is I'm going to line up these different pieces. So X has to go with my 20. I have to solve for the X. And it doesn't matter how the other one is set up. So I could either do my 9 with a 12, or I could use the 12 with a 16, and it really doesn't make a difference. So I'm going to use my 12 with my 16. So when I cross multiply these, I get my 16x equals 240. When I divide it by my 16, I get x equals 15. So on this one, we want to solve for x and for y. So we want to look at which sides are we paired up together. And I want to label, I have a big triangle and I have a small triangle. I usually set mine up as the left over the right one, so I do the big is on the left and then the small is on the right. Alright, so I have my 9 and my x. So if I want to solve for the x, I know one of my ratios needs to be 9 over x, and then I need to set it equal to something. If I want to find my y, I need to use my y with my 4, so my big over the small triangle, and then I need to use a ratio on the other side as well. So the other side needs to be just two numbers, so the only other two sides that I could use is my 5 and the 3, and I'm going to use that on both of them because I need two numbers for both of them. So there's my setup for my x and for my y. So when I cross multiply, we will get 5x equals 27. So when I divide by 5, my x gets 5.4. Then for the y's, when I solve for y, I cross multiply here, which means we'll have 3y equals 20. When I divide by 3, I get y equals 6.6 repeating, so I'm going to say 6.67, or you could leave it as a fraction as 20 over 3. Alright, so this is just something that I want you to notice. If you're wondering, are congruent figures also similar? So remember, congruent means that all the pieces are exactly the same, like we've got in these two triangles right here. And we can say that they are similar because if we set up the ratio, so congruent triangles are also similar. You might want to underline that part of it or write that statement down in bold. If their scale factor is 1, so 1 to 1, that means that they're congruent. But they do have the same scale factor, so they are congruent to each other, and they are also similar. So for corresponding lengths in similar polygons, we can set up any sides, any corresponding pieces of the triangles, and then that is also equal to the scale factor. So some other corresponding lengths that you could use in a triangle could be the sides. We have dealt with medians before, which remember that connects the vertex to the midpoint. Next we have the altitude, which the altitude is just the height of the triangle, so from the vertex 90 degrees on the opposite side. And lastly, we have midsegments, which is connecting two midpoints together on the sides of our triangle. Alright, so put a big star next to these type of questions right here. And first we need to draw a 15-foot tall climbing wall, and then we need to draw a building that is larger than it. And the height of the building we do not know. Next, we have shadows. So here's my shadow on the ground, and my climbing wall, it has a 20-foot shadow. My building has a 32-foot shadow. And if you notice, I'm color coding it to make it a little bit easier for our setup of our proportion. So we do need to set up a proportion and find the height of the building. So we can match up our blues together. So my 15 over x. and then I can match up my corresponding red shadow numbers together. So if you notice, I did the wall over the building numbers. So we're still keeping that same pattern, and then we can cross multiply to solve this. So I get 20x is equal to 480. When I divide by 20, I get a 24-foot building. All right, so for the next one, we have a rectangle is 15 centimeters, and that's for the length of it, so the length of one of them. We have another rectangle that we don't know what the length of it is, but we have the scale factor is 2/3. So we're going to be using our scale factor of 2/3 and our 15 and our x then to solve for our missing side. So we will get a 2x equals 3 times 15, which gives us 2x equals 45. When I divide by 2, I end up with 22.5, and that'd be centimeters for the length in that other rectangle. I like this picture just because it is very visual, and the same thing is going to happen with our little pieces. So we have 2 ladders leaning against the wall. We have the actual length of the ladders right there. This length of the second ladder we do not know, so that's our x. We have the height of our ladder, the 30, and the height of this ladder is our 10. So we're going to color code it as well. And let's do our larger ladder numbers over the smaller ladder numbers. So for the actual length of the ladder in red, we have our 54 feet over our x that we need to find. Then we have the height of the ladder, so our 30 over our 10, and then we can cross multiply to solve this. And we will have 30x equal to 540. When we divide both sides by 30, we end up with 18. So that means our second ladder is 18 feet long. There you go.